Okay, in lesson 9, we're going to look at simplifying, expanding, factoring, and distributing expressions. It sounds like it's a lot, but it's actually fairly easy when we look at some examples. So the first thing we're going to look at is simplifying. So notice in the directions it says to write each expression using the fewest number of symbols and characters. Use math terms to describe the expressions and parts of the expressions. So letter A shows us that we have 6 times b. So to simplify this, it just means that we can take out any symbols that are unneeded. We can do any multiplication that we can actually do. We would do all of these things. So if I have 6 times b, with algebra, we don't need that multiplication symbol to show we're multiplying. So all we would do is write this as 6b, taking out that multiplication symbol to simplify the problem. Looking at letter B, there's some math we can actually do here. We can do that 4 times 3 first and get 12. 12 times h can just be written as 12h. So we've done some multiplication and taken out the multiplication symbols. With letter C, we have 1 times these. Anytime you're multiplying with 1, you really don't need to write that 1 down to show that you're multiplying it. So we can take that 1 out. We can take out the multiplication symbols. So really, we're doing r times s, which we would just write as rs. So it's simplifying in these cases are just taking out those multiplication symbols and doing any multiplication that you can. Okay, example 2, expanding expressions, means to expand multiplication expressions, we rewrite the expressions by including the multiplication symbol back into the expressions. And there is another piece to this that we'll look at when we get to letter C. So letter A is 5g, which means 5 times g. So to expand that, I would just put the multiplication symbol back in it. Now, with 5, there's no way to make 5 with multiplication besides 1 times 5, so we would just leave this the way it is, 5 multiplication symbol g. Looking at letter B, we have 7abc, which means 7 times a times b times c. So once again, we're just going to put the multiplication symbols back in. If we were doing this in the computer, we would use the star symbol for multiplication. So just so you're aware, when you're doing homework or in PlayPosit, you would want to use that star symbol, okay? Now, the next one is just a little bit different. We have 12g, so that means 12 times g. However, we can expand this even more. The way we can expand this is there's ways to make multiplication other than 12 times 1. And the way that you can do this is by doing something called a factor tree. Just to go back, 5 and 7 are both prime numbers, which means you can only make them by multiplying them by 1. So 5 times 1, 7 times 1. But we can make 12 in other ways. So what we would want to do is we want prime numbers like we have here. So we would make a factor tree for the number 12. And to do that, you put 12 up top. You're going to make 2 branches off of the 12, and you're going to think of a multiplication problem you can use to get 12. And there's a couple of different ways to do this. We could do 6 times 2 as 1. Okay. We could also do, and I'm just going to pull a separate one over here, 4 times 3. And order doesn't matter. If I had done 2 here and 6 here, that's fine, or reverse these. Either way, it's going to give us the same results. So now what we do is we continue branching off of each number from the branches. So with 6, I can make 6 by doing 2 times 3. With 2, I can't make 2 with multiplication other than 2 times 1. So what that means is 2 is a prime number. So what I do when I get to a prime number is I circle it. So now if I come down here, I have another 2, so I would circle that. And then 3 is also prime because it can only be made with 3 times 1. Okay, so what this is saying is I can make 12 by multiplying 2 times 3 times 2. Those are all prime factors. So that will help us to expand 12 into as many parts as we can with multiplication. If we do the tree using 4 and 3, it's still going to work out the same way. I can make 4 by doing 2 times 2. 2 is prime, as is 3. So notice 2 2's and a 3, 2 2's and a 3. So it doesn't matter what you start with, you should still get the same result. So when I write this in its expanded form, I want to write 12 as the 3 prime numbers multiplied together. And typically you do this in numerical order. So I would do 2 times 2 times 3, and then don't forget that G. Okay? The next piece is factoring. And we've actually kind of already done this year. Factoring is to rewrite the expression using the distributive property. So for example, if I'm looking at 21 plus 35, what we did is we used those two numbers with our ladder method. We found a number that goes into both of them. In this case, it would be 7. 7 goes into 21 3 times. 7 goes into 35 5 times. So we would take our GCF, which is 7, put it outside a set of parentheses, and inside the parentheses, I would add the bottom two numbers from the ladder. Okay, so this was our GCF, and these were the bottom two from the ladder. Okay, so that's how we factored some problems before, and this is where it's coming back into play now. Okay, so looking at number 2, it's asking us to factor 24b plus 8. So it's asking us to do the same thing we did in number 1, but now it's including a variable. Okay, so what I'm going to do is I'm going to write this as 24b and 8. And I'm going to do my ladder method. Now, a common factor can be found between 24 and 8. So what I would do is I would pull the same thing out and basically just ignore this variable for the moment. So 8 and 24 can both be divided by 8. 8 goes into 24 3 times, and I'm going to bring that b right down with it. And then 8 goes into 8 1 time. So I can rewrite this with the distributive property in the same method. My GCF is 8, and then at the bottom of the ladder, I have 3b plus 1. So it's the same thing, it's just carrying down that variable. So now it's asking us to evaluate both expressions if b is equal to 2. And by both expressions, they mean the original and the one that we just did. So if I'm going to do the original, I'm going to put 24b plus 8. I am going to replace the b with the 2. Don't forget that you should expand this. So I would write 24 times b plus 8 to make sure that I'm doing it completely correct. I'm then, after I've expanded this, going to replace the b with the number 2. And then I'm going to follow the order of operations. So I have multiplication and addition. I would do multiplication first to get 48 plus 8. Do 48 plus 8, and I'm going to have to write it over here because I'm out of room. And that gives me 56. They want me to do the same thing with my newly distributed, or factored I should say, expression. So once again, I'm going to start by expanding the 3b to 3 times b. Always recommend doing that. Then I'll replace the b with 2. And then I'll follow the order of operations. So inside my parentheses, I have more than one operation. So I'm going to box in the multiplication problem only first. I will complete that, which is 6 plus 1. Okay, and then now that I have one operation left inside the parentheses, I box it in. This, remember, 8 means 8 times that, so I could have probably also expanded that there. Do my times, and then 6 plus 1 is 7, which gives me 56. Okay, so as you notice, because they're equivalent expressions, the 24b plus 8 and the 8 times 3b plus 1, they should be equivalent. They are, because we're getting the same exact response, just the math is a little bit different. Okay, so the next one is asking us to factor the expression. It's the same idea as the last example, except it's a little different because in both of these cases, we have the letter C. So when we go to do our ladder method, if you look at the numbers, 3 and 11 don't have a common factor. But since they both have a C attached to them, that would mean C is a common factor of those two numbers. So at this point, what we would do is if you're pulling out the variable, C divided by C is just 1. So that means we're just going to pull down the number that's there because 3 times 1 would be 3. And I'm just going to pull down the 11 because I'm taking out the C from it. So our GCF in this case is a variable. The C is our GCF, and the bottom two numbers go inside. Okay, so now they want us to evaluate the two expressions, our original and our newly written one, as those if C were 3. So I'm going to write the expression. First, I'm going to expand it. So put the multiplication symbols back in. Then I'm going to replace the variable with 3, since it's telling me C is equal to 3. Then I'm going to do the order of operations. So multiplication comes before addition. I have two multiplication problems, so I'll work left to right. 3 times 3 is 9, plus 11 times 3. I'll do 11 times 3 next, which is 33. And then I'll get my answer of 9 plus 33 as 42. Now I should get the same response over here. So I have C times 3 plus 11. I'm going to expand it, C times 3 plus 11. I'm going to replace the C with 3. Okay, and then what I'll do is I will do my parentheses first. So I will do my 3 plus 11, and 3 plus 11 is 14, and then when I do 3 times 14, I, once again, get the matching answer to this, 42, as I should since they are equivalent. All right, so that is showing us simplifying, expanding, factoring, and distributing expressions.